Hello guys, my name is Patrick Haragut. Um, Today we're gonna do a kind of like a world UV projection, but we're gonna extend this projection to follow the player position, so we can kind of use a limited space render to texture, so kind of create like an infinite render to texture. So this way you can have like a single camera render a texture and spread to different objects and seamless to kind of apply some masks or effects that you want. Let's first like create a texture so we can apply a texture to see. So I have like a material here and we're gonna apply some kind of like number things. Okay, so this is kind of object space. If we check the object, the UV object, you know, if you scale the UV follow, so we're gonna create a world UV space based on the Z and the X. So X will be the U and Z will be the vertical for UV. So to create this, we're gonna need like a world position node. So this is the world position node. First things we're gonna do, it's kind of like do a component mask. Scale. So we're gonna mask this case, sorry, X and Z pass through. When you pass here and update, like this is basically like a UV space on world based, so it will be 1 and 1. If we create like a cube here, we can kind of measure this thing, but because like the UV start on 0, so let's offset like this, like a 0.5 and 0.5. So this is kind of like our UV space, right? So to us get the right scale for this, we're gonna divide our scale to a value. So this value will be like float, like the float can be an int. So it's world UV scale. I'm gonna create here. So divide by 0, 0. So forget to change the property. Let's set a default value for, I don't know, 4, just to have a default value. Okay, this way like you can scale your UV based on something. We're gonna use this scale to match the camera render to texture camera. Okay, for now I put like a texture that's not it's not tileable, but if you put tileable, that's it. Okay, so basically this is like a UV space based on the world, but if we return here, our UV start on 0, 0. That's something that we don't want because we're gonna render to texture, and let's say the sphere is our player. We want the UV to be center. A way to fix this, we're gonna insert like a scale offset node. right? And we're gonna put like a 0.5 and scale and 0.5 on offset, so you're gonna center the texture. Okay. Okay, basically like this is world space UV on center, you know, starting like centered. To kind of have like to pass the position of the player to us offset the UV, we're gonna create like a vector tree. Okay, this vector tree I'm gonna call like I'm gonna set a global variable, so we can only set up or access this through script. But at the same time, if I have one script like a setting this global variable, all the shaders will receive this information. If you know, all the shaders you put like the same global variable will receive the information of the position. So I'm gonna call this like a player position. So this is the name of the property. So one thing I want to do first is kind of like isolate the y value, because I just want the z and the x, so I'm gonna ignore the y value. Okay, so we're gonna keep default. So how we're gonna do this? We're gonna append a vector tree, so x, z, and the y will be always 0. So to do the calculation here, to offset the world position, we're gonna just subtract. So subtract the world position from the player position. We're gonna get the UV offset for this. Basically is this. So let's do a quick script, because now like if I move this here, nothing happens. So let's create like a new script here. Gonna assign to this here, and we have the script here. So let's create the script. So what we gonna do, we don't need a start method, so we're gonna just like create like a serializable field. We're gonna pass the transform position on the player. Okay, let's new for start. If player not equal new, then we pass the value just to not drop an error. I'm gonna pass like a shader, right? Dot set global vector. What's the name of our property for the global vector? It's player position. And what we're gonna pass is the vector player, the position. Okay, so now if we save, let's wait it's compile. Sorry, just to demonstrate not execute always, whatever. This is just to kind of run on editor. So yeah. So we're gonna pass the player position. Then if you move or UV follow the player, right? What we're gonna do here is like, let's get this floor and assign another texture. Okay, this is tileable. If we move, they're gonna move, but it's not what we're gonna do. Let's duplicate this floor, move then like -1, and assign, and let's create a new material. Can be a standard material. Reference. So here we're gonna put let's put these numbers here. Okay, so if you hide here, let's assign this to this. So now have a look at this floor reference. This is gonna be rendered to texture. Okay, so I'm gonna put in a different layer. Put in layer A, so everything is on default, right? So this is layer A. Let's put like let's create like new camera here. Camera RT. It's gonna be solid black or whatever you want. Instead, perspective will be orthogonal. I'm gonna rotate the camera 19 degrees. And okay, 0 and let's say 10. And these cameras will handle only the A, so we can see the so let's create a render to texture. Render to texture. Okay. $250, $250. Okay. So let's assign. Let's assign here, and let's put the camera. This camera 1 0 1 0. So it's right on the center. Okay. Let's say your size is 5 or 10, whatever. Let's tweak this. It can be this, just us. Let's make this bigger. Let's say 10. 10. Yeah, 10 is okay. Just 10. So on our floor now, we're gonna assign the render to texture, right? Yeah, the camera, like, let's put the camera inside here just to us see the effect. So when we move, we're gonna render like what's on the bottom, you know, but it's not 100% right. Should not be moving because our material on the floor have a different scale. So if the scale is the same of the camera, if it's 10 and the material is using the same scale, everything is gonna match, right? So this way we can kind of like go back to the shader, get the player position, like, and do like do just a sphere mask. gonna use the player position for the center. Let's create like a radius. Just mask and property and just mask. Okay. Property and then okay, and then we're gonna let's just do a lerp here so we can mask. So black, white, and the mask. Right. I update it on the floor material. We're gonna let's say the same as the 10 and I think we need to invert. So basically now we're gonna just render this this space inside the mask, and you cannot see the tiling or the the limits of the textures. So this is basically the concept. What's happened, like if you have like a let's create like some cubes here, different cubes, different scales. Same material for the cubes. So when you move, like the cubes are receiving the same projection. Right, so this is the way like you can have like a different effects in different floors and kind of like make this infinite. Let's put the render reference render on the back too. So this way you always kind of like have the render to texture following the player. So just a quickly thing that this is just an example. So if you rotate this, you're gonna break the thing, right? Because the camera is inside the player, and it's not the way we want to do. The way we want to do is kind of like let's get back on the script, and then we can instead put like these scripts on the player, I'm gonna remove, and you're gonna put the script on the camera. So we're gonna put the script on the effect camera, right? And then we pick the player, or you can find the player, and like here we're gonna here we're just gonna say like a transform dot position equal player dot position. Let's put inside here to not get any error. So this way the camera will follow the sphere, but it's not gonna rotate, it's just the transform, just gonna follow the transform position. So everything's still working, but if you rotate, not happen because the camera is not rotating, just just keep in mind that it's just an example, so expect you guys to extend this and do really cool effects. So that's it. Thank you so much. See you later. Bye.